Okay, Assalamualaikum and good morning. Today we'll continue on commercial and industrial air conditioning control system. Okay, first one is water cool package unit. It's much like the air cool, but for water cool the condenser is mounted within the unit. Okay, this is the drawing of water cool package unit. It has condenser pipe, water in, water out, power supply, thermostat, selector switch, and airflow in and out. Okay, this is the operation of water cool package unit, where you use water as a medium to reject the heat of the condenser, and then it's being pumped to a cooling tower, where the heat is then rejected in the cooling tower. To ensure that the compressor is safe and has interlocking system, which the compressor will not work without the cooling tower pump is being operated. If not, the compressor will only compress air without the water. Water cool package unit also has a line voltage control system. Let us see the diagram. Okay, this is a schematic diagram of water cool package unit. So, for example, here we have a contactor, legend of C, compressor, BM lower motor, T here is thermostat, LPS low pressure switch, high pressure switch, CWI condenser water interlock, and last one is switch. So this is switch, on and off. This is contactor. It have 1, 2 and 3 contactor. First one direct from live 1, second from live 2, third one is from live number 3, and then it has this is blower motor, and it has this is switch, it has thermostat, low pressure switch, high pressure switch, condenser water interlock, and the last one is what? Relay for the contactor. Okay, how does it function, this circuit? So for example, here we have the switch is in off and fan, so means the fan, this is line of fan, this blower motor will operate, although the compressor is not operate, but the blower is operate. Okay, I mean the fan is moving. Okay, how to make this compressor functioning? So to make this compressor functioning, we have to energize this relay. So when this relay energized, what happened? All these three contactor relay normally open. Contactor relay will be changed from normally open to close position. Okay, but to make this one function, this CWI condenser water interlock has to be closed. So it has to sense there's water inside the system. And then we have at the same time the high pressure switch and low pressure switch has to achieve the desired pressure that we set. For example, this one is not too high, if the compressor or the system is too high pressure, then this one will be open. If the pressure is too low, this one will be open. So you need to have the pressure that we set. And then the thermostat is to measure the room temperature. So if it's high temperatures that the setting, for example, we set 24 degree for the room, it achieves 26, then this thermostat will be move from down to up in position and touching this point and make this line has the currents, and will energize this relay and make the compressor running. Okay, if you look this kind of switch, it has a shape like this, means it has two positions at the same time, 2 points. So if it moves to here, so this fan and this sensors will be functioning at the same time. So there will be an air blow towards the rooms. At the same time, there will be the compressor is running. Okay. Okay. Type of total commercial and industrial control system. Okay. The commercial and industrial control system is to control the entire HVAC systems. It's a bit complex because we have to control the comfort level of the entire structure. So to control the comfort level of the entire structure, we have to controlling the air supply, the hot water flow if we need. Then this is control the temperature. Then we have to deliver the hot water for the heating. The structure is for heating season. And then cooling system, whether to be chill or large condensing units. Control the humidity, and also we have to control the ventilated air and energy management, when it should be on and off. Okay, before this, the control system is being monitored by operator to monitor the monitor and regulate the temperature. And for modern one, it's being controlled by modern electronic control systems, centralized by computer console. Alright, to have the control systems, is normally they use control loops to control the temperature within the given structure, space or zone. So before we could control space or a room, for example, we need to have the inputs from the connected space. We have to know the temperature, perhaps the pressure and the humidity. Okay. Or the airflow would be. Okay, by having all of this data, all of these parameters, then it means taken the signal into the controller, or controller means microchip, and to read the data or the input that being sensed by the sensor. And then we have another one is control item, controller device to control to maintain the desired temperature. For example, if the temperature is too high, so what happens? It will cut off. Too high, it's been cut off. Normally it will go like this. This is pressure, you see. So okay, if the temperature is too high, then the system will be operates. And for example, this is for our, it reach to 26 degrees Celsius, then what happened? The system will be operated, and so on. Same goes for the humidity and also for the flow. If there is no airflow, so for example, there's no airflow inside the system, the compressor will not run. Okay, so depend on the programming. Okay, this is basic control loop of a room thermostat controlling a condensing unit. So for example, we have first one is sensor, right? Sensor room thermostat. This is only thermostat. For example, it has to measure the temperature. So when the temperature is high, then what happen? It will send calling for cooling from controller that control the aircon system or the microprocessor. So what happen? It send a signal to the compressor to start the compressor, and then compressor move, and the sensor sense the temperature reach 24 degree. If we set 24, then they will send a signal. This one should be off. Oh, its inverter is being slowed down to maintain the temperature at 24 degree. Alright, here the description lah what happened for this. Yeah, just go through it. It has humidity, airflow, thermostat for the sensor of the room. Okay. Okay. For this we have only thermostat. Oh yes, it has only ambient, or it has only airflow. So here, for example, it has advanced control loops. See, advanced control. It has more than one input and more than one outputs. So as I said for this, maybe it's advanced one. So it has temperatures, it has pressures, it has airflow, it has humidity. So we call a controller call a device to make it function. Then this is being satisfied. Okay, control system. Basically, there are three mechanical control systems used for commercial and industrial. So what are they? They are mechanical / electrical, pneumatic, and also electronic control system. Okay, in the early stage, it uses mechanical or electronic control system to stop and start the loads to maintain the temperature in the structure zone of room. So here we could see what are the mechanical or electrical control system. There are thermostat, cooling contactor, hot water valve. These are mechanical and electrical control system. Next one are pneumatic control system. Okay, in pneumatic control system, we use air to transmit the signal from the sensor to the controller and also to the control device. So signal from the sensor to the controller. So how it been done? Okay, here this is thermostat, but this is pneumatic thermostat. So pneumatic thermostat means it use air. Sense hot, but it use air to send the signal to the controller. Controller is IC lah, okay, or microprocessor. And then the signal and to the control device. So control device, this one I will send you a YouTube video for you see the control device, pneumatic one. The control signal in the air is carried from the sensor to the controller and onto the controller device through a small pipe, usually 1/4 inch or 3/8 inch. Okay, for the control device, it can be modulating because the pressure we could increase or decrease depending on the sensor. Okay, this is diagram of basic pneumatic control system. For example, you have a room thermostat, and then it has a hot water over here, and this thermostat or controller is being actually control this valve of hot water in, hot water out, and return to boiler. And then this is out branch. So here I open this book, ebook, because the one in the slide is not does not have this figure. So actually this above figure 17.29, desired to maintain constant temperature of air temperature at desired set point by modulating the hot water coil heating valve. So what happened? This is controller. Okay, from thermostat is a controller. So it has a sensor over here. Go right to the controller, and this controller is control the valve of what? Of hot coming water. Okay, here drawing of basic pneumatic control system. For example, here it has a room thermostat to measure, to sense whatever parameters that it needs from the room, and then send to the controller. This is controller. So what is controller? Controller will sense or control the output, desired output. So here it control the valve, normally close hot water valve. So normally closed means that when it needs, it will open because it's normally closed. And the other one, this controller also control the three-way valve. This is also normally closed, three-way valve. Okay, so this one for cold side. Okay, what are the advantages of pneumatic control system? Simply, easy to understand, safe, explosion proof, very versatile, reliable, and cost installation may be less. Okay, the above slide you could read by yourself. So I directly go to this main control component. Okay, there are three main control components, which are the sensor, the controller, and the actuator. So what are the sensors? The sensors are devices that sense desired temperatures and relay them to the controller by supplying specific air pressure representing a specific temperature. So here, for example, it sense air pressure, then the controller will calculate what are the temperature. Okay. Sensor could sense temperature rooms, the return air temperature, the supply air temperatures, and outdoor air temperatures. Sensor, whatever sensor, this is temperature sensor actually. Hot water being supplied to the boiler, the chiller water temperature is being supplied from the chiller. So whatever temperature being sensed will be sensed by sensor. Specifically for temperature is temperature sensor. Okay, next one is controller. Controller is to receive the input from the sensor and determine the action of the actuator to perform the necessary function to equipment, damper, valve, and so on to maintain the desired condition. Okay, so controller actually the microprocessor lah, right? Whatever come into it, if it count what to do, but it also been programmed actually what to do. So if you need to close a valve, you close a valve. If you need to open a valve, you open a valve. If you need to switch on and switch off, or you need to regulate the damper, for example, to open or not, or to open half speed. And okay, this is the last one is actuator. Actuator is the ones that doing the job. Okay, the controller sends a signal to the actuator, and so the actuator will move the valve, move the damper, or move whatever equipment that you have. So here it's say that it's move, it use pneumatic relay which control the equipment. Okay, so this is example of pneumatic relay. So when it being energized, what happened relay? So it will control the other equipment. Okay, here is an example of pneumatic control system. Okay, and the same goes here. Okay, being direct back to this figure because this is direct digital control. What is direct digital control? The controller that has these sorts of device: sensor, controller, and final control device or actuator. FSC. Okay, what is the advantage of electronic control system or direct digital control? Operates on a very low voltage. It can give variable signal to the control device, which will allow the control device to modulate between full open or fully closed, like pneumatic control system. Okay, then the components are much smaller and easier to work, and could control the variable speed motor. This is electronic control device. Direct digital control also use microprocessor act as digital controller. Direct digital control system works similar to the conventional control system, pneumatic, electronic, and electromechanical, except the speed of this control system is faster. It uses binary information which is based on two things or parts. Binary is 1 or 0, 1, 0, 1, 0. Okay. Okay, the microprocessor also could control two signals much faster than could be handled by other type of modulating signal. The system also could take analog signal and convert to digital or binary signal and pass through the microprocessor and convert the signal back to analog signal that can be used to control the device. So regardless of your sensor, if it's analog sensor or digital sensor, it could be convert and sent to the microprocessor, and it will be converted back to analog or digital depend on the actuator. If for example you have analog sensor and then digital actuator, this microprocessor could do it very easy. Okay, basically these are procedural drawing of converting analog signal to direct digital signal. Input signal information, whatever sensor it has, and then go to the termination board. This is direct digital controller or the CPU board or the controllers, and then if it's analog to digital converter, and then go to the CPU bin process, and then digital to analog converter. It being converted to analog because this is analog. For example, you have a fan is analog, so direct to analog, then the output will be function. Okay, this is input and output of direct digital control. So what are the inputs? Not only direct digital control, for all controller. Inputs are supply air temperature, return air temperature, outside air temperature, mixed air temperature, enthalpy control. This is example lah. This is all temperature sensor and one also enthalpy control. Direct digital control, then this one process and go to the fan controller to move the fan, to move the damper, and to heat. This is valve, maybe cooling control. This is valve, maybe to control the valve, or control the compressor. Okay, there is a set of instruction programming one that already been programmed inside the controller. So whatever sensor coming in, whatever data is coming in, it will be count or be computed by the controller, and it will determine the output need to be done and send that to the device or actuator to maintain the room condition or structure condition. Okay, this is an example of computer monitoring and control holding condition. For example, it has one computer here located at remote locations. So it has data come from the building. So whatever the data they have, for example, here it has outside air door sensor. Maybe this one is humidity or temperature. Then being converted to analog to digital. And if this is analog, then it will convert to digital. Digital come on and go to this computer or CPU or IC or microprocessor. So being calculated by using the program that you already programmed inside this computer. What happened? It send a signal. This is digital signal. Digital signal, if it's this is actuator or a fan or device. So if it's analog device, so you need to convert back this digital signal to analog. So being sent, so this analog and the fan will be both analog sensor. Okay, and then for example the other one is digital output sense, then being convert to analog or digital device. Regardless, this one is regardless, analog, digital analog, and then this 3-way valve, if it's analog, then convert to analog. If it's digital, then directly to this one, not need to convert. Okay, so what are the valve for? The valve is to slowing down. This is flow of water. Flow of water. So slowing down the water or stop exactly. No water movement. Alright, direct digital control use energy management for structure in many cases and responsible for comfort condition in a structure such as energy management, lighting, and fire protection. So, for example, you have fire protection. You have to protect a building from a fire, from light. You have to know what is the lighting and what is energy. So this all data is being sent, being calculated using digital control system. If for example it's too hot, if there is fire for example, then the compressor or the damper will be closed and the compressor will be cut off. Alright, thank you.